All right, so what we have learned and what we haven't learned. And what I'm really talking about here is kind of the main drawback to these analysis of variance tests if you don't do additional statistical testing afterwards, which we're not going to talk about, so this will remain a drawback in your lives. And the drawback is that the analysis of variance test tells you that we have evidence that the mean levels of something in different populations are not all the same. But they don't tell you which groups, if any, which groups are different from each other. So here again is plotting this made-up data that I have, death penalty support for Asian, Black, and white groups. And these are the same means that I showed in the example. So what analysis of variance told us is that we have pretty good evidence that, these means reflect differences in the population. That not all three groups have the exact same level of death penalty support out there in the population. But what it doesn't tell us is which groups are different from each other. So do we have evidence that the white people are more supportive of the death penalty than Black people? That Asians are more supportive of the death penalty than Black people? That white people are more supportive of the death penalty than Asians? So we can see the numbers here, and we can see which groups are higher, but we don't know which groups are actually statistically significantly different from each other. Because it could be that, Asian and white people have the same attitudes about the death penalty, and those attitudes are more supportive than Black people. It could be that Asian and Black people have similar attitudes about the death penalty, and those attitudes are less supportive than white people. We just don't know based on the data that we get from analysis of variance. And there are additional statistical tests that can be done. Again, we're not really going to go into them here. But what you should know is that if you see an analysis of variance test and it says that it's statistically significant, the only thing you know is that the means on whatever the variable is are not exactly the same as each other. But it could be that one group is different from all the others. It could be that all the groups are different from each other. And we don't get that information from the analysis of variance test. All right, so I want to just go through a quick summary of the hypothesis tests for means that we have met so far. Because the next things that we're going to do in class after Thanksgiving break are going to be slightly different than what we've been doing here. So we met the one sample t-test, which allowed us to answer the question, is the population mean value of some population equal to a particular number? And when we do this test, we reject the null hypothesis and conclude that the population value is not equal to whatever number it is that we decided on. So here we're just looking to see whether the population mean is equal to some number. The two sample t-test allows us to answer the question, are two population means equal to each other? And if you reject the null hypothesis in a two sample t-test, you have evidence that whatever two population means you're looking at are not equal to each other. So that there's some difference between two populations on whatever variable it is you're looking at. Analysis of variance allows you to answer the question, are three or more population means equal to each other? And if you reject the null hypothesis in an analysis of variance test, you conclude that all of the population means are not equal to each other. So if you ever need to answer questions like, is a population value equal to something? Are two groups the same? Or are three or more groups the same? You should be able to choose between these different hypothesis tests and know which the best one to use is. You should also be able to interpret the results of t-tests and analysis of variance tests if you ever come across them out there in the world, for example, in classes that you might take or articles that you might read because of classes that you take. And then for all, just as a reminder, you follow the same steps, which are to write null and alternative hypotheses, to determine a test statistic, whether that's T or F, and then to use that test statistic to calculate a p-value that allows you to decide whether to reject the null hypothesis. And the last thing that I'm going to leave you with is just to show you that, as with everything we do in this class, I'm making you do it by hand because I want you to know how it works. But typically, if you're doing research or if you're reading research that's already been done, all of this is going to be done by a computer. So I just want to quickly show you the output for t-tests and Anova in SPSS, which, as I mentioned, is one of the big statistical programs, mentioned much earlier in the semester, is one of the big statistical programs that are used in research and by government agencies and so on. And so it takes a couple clicks to get to something like this. So this is data that's looking at identification as liberal or conservative based on gender. So we have male or female respondents, and then average scores on how liberal or conservative they think they are on a scale from 1 to 7. So the first thing that we have here are the means, standard deviations. We're ignoring degrees of freedom for the moment, other than that tells you what shape your sampling distribution is. We have a mean difference, which was what we were talking about all of last week. We have the standard error for the sampling distribution. We even have a confidence interval if you look there on the right. We have a t-score for our difference in means. And finally, we have a p-value. And so here we have a p-value of 0.354. It's bigger than all of our traditional alpha levels. So we would probably assume, based on this statistical test, that men and women are about equally likely to identify as liberal or conservative. And again, the point in going through this is really just to show that everything we're doing in class is what gets spit out by statistical programs when you have them do these calculations. So the goal here is to have you guys know what these things actually mean if it comes time for you to do this kind of analysis. So here we'd say that there's no statistically significant difference in political attitudes among men and women. This would be an example of Anova. So this is using the General Social Survey, which is one of my favorite surveys. The categories they have for race by one of the questions is just white, black, and other. And this is going to be the same question. So do you think of yourself as liberal or conservative? So here we have means, where higher scores is equal to greater conservatism. We have an F statistic, which is what you guys just calculated. If you look over there, we have the mean square for between and within groups that didn't get highlighted, but when we also have a p-value. So it's all the same components that we just went through, but this is, again, what gets spit out when you do this sort of problem in a statistical program as well. And what this shows us is that there are statistically significant differences in liberal and conservative identification among these three groups as well. All right, so that's all I have for you guys today. Last week before Thanksgiving, so have a great week this week and have a great week next week too. And happy Thanksgiving.